Hi, welcome back to the second video session. Here we are continuing the topic that we have been discussing in the first session. So we are going to start with, and we are going to do some problems, some exercises on discrete convolution. Now, this discrete convolution, say for that you consider two signals x1 of n and x2 of n that can be finite sequence or infinite sequence. So in this video session I'll be dealing with the discrete convolution of finite duration sequence. Now I'll just have a recap of what finite duration sequence is. I'll just give you I've given these two examples, x1 of n and x2 of n, which is 1 2 3 and 1 2 1. Now looking at this, you have the similarity between these two signals is both are having the same samples, that is 3 in number. We are designating the number of samples to be n1 and n2 respectively. So in this case also you have 3 samples. Now the difference is the starting point of x1 of n is not the starting point of x2 of n. x1 of n starts at n is equal to 0, so the starting point is denoted by sp1 is equal to 0, x2n being the 0, the starting point is from -1, therefore sp2 is -1. So the finite duration sequence, by finite duration sequence we mean that you have only finite number of samples in that. So for example, if you have already aware of u of n, we know that u of n is having a value 1 from 0 to infinity. That means that is an infinite duration sequence. Okay. Now, while what is the meaning of discrete convolution? Discrete convolution is you are convolving x1 of n to x2 of n. So when you convolve these two signals, that will be another time domain signal x of n. So that also will be having a finite sequence, and that will be also having a starting point. Both has to be analyzed, both has to be found out before doing the problem. So the number of samples this convolved signal will be n1 plus n2 minus 1. In this example, this is going to be 6 plus 6 minus 1, which is equal to 7. And the starting point, the convolved signal also starts from the sum of the starting point of the signals which are convolved, that is sp1 plus sp2. In this example, this will be -1. Now you will be understanding in a clear way when we do a problem. So for that we consider two signals, x1 of n and x2 of n. x1 of n is 1 2 1 1, x2 of n is 1 1 2 1. You are asked to find out the convolution of x1 of n and x2 of n. Now before proceeding, we should have an idea about the number of samples of this convolved signal as well as the starting point. What is the number of samples? This will be n1 plus n2. What is n1 here? n1 is equal to 4, n2 is also equal to 4. What is the starting point? sp1 is equal to, in this example it is equal to 0, sp2 is equal to -1. In this x2 of n it is -1. Okay, so now what is this? N is equal to n1 plus n2 means n1 plus n2 minus 1. So this is equal to 4 plus -1, which is equal to 7 samples, while starting point is sp1 plus sp2, which is equal to 0 -1 -1. So what you understand before doing the convolved, you have an idea about the convolved output. The convolved output will be having 7 samples, and the convolved output starts from n is equal to -1. Now let's start doing this problem. Now to do this, to evaluate this problem, you can have 3 methods. There are 3 methods by which you can do this problem. They are: number 1, direct method. That is, by direct method we mean we are simply using the straightforward mathematical equation. Number 2, it is a graphical method. Number 3 is the matrix method. Okay, now Let's start with the direct evaluation method. What is this direct evaluation method? So, when you perform your direct evaluation method, you are using the expression x of n is equal to x1 of n star x2 of n. What is that expression then? It is sigma k is equal to minus infinity to plus infinity x1 of k into x2 of n minus x2 of n minus k. Now, we have already found out from this, here the starting point of this convolved signal is minus 1. So that means n should start from minus 1 up to minus 1, 0, 1, 2, 3, 4, 5. You have 7 samples. That means you should have the values from n is equal to minus 1 to 5. So put n is equal to minus 1 in this equation 1 in 1. So putting equation, so that equation becomes x of minus 1 is equal to sigma k equals minus infinity to plus infinity x1 of k into x2 of minus 1 minus k. Okay, now you need to expand the summation. Now to expand the summation, we know that, see, consider this x1 of k. When k is equal to 0, you have x1 of 0 to be 1. K is equal to 1, x1 of k is equal to 2. K is equal to 2, x1 of 2 is equal to 1, and x1 of 3 is equal to 2. Now what happens when k is equal to 4? When k becomes 4, it becomes x1 of 4. Now from this question, we can see that x1 of 4 is 0. Similarly, if you have the negative values of x1, all the negative values of x1 is 0, right? And in the second signal, you have only one value for the negative value, that is at minus 1, then all other are positive up to n is equal to 2, minus 0, 1 and 2. Now what happens when, what is x2 of 4? x2 of 4 is also equal to 0. So you will be having only limited products, and all the other products of x1 of k and x2 of minus 1 minus k is going to be 0. So in order to find out, it is recommendable to start from 0, from putting k is equal to 0. So when you put k is equal to 0 in this summation, you can expand this. Okay, let's start like this. You all must start like this. It's recommended to do like this. So it is x1 of 0 into x2 of minus 1 minus 0, which is x2 of minus 1, right? Then plus putting k is equal to 1. So this is sigma k is equal to minus 1 2. So you are putting it from 0 to, so this will be x1 of 1 into x2 of minus 1 minus 0. No, 0, it's not 0, it is 1. So minus 1 minus 1, which is equal to 2. Then next is x1 of 2, that is, you are putting 2. When you put 2, x2 of minus 1 minus 2, which becomes minus 3. Now similarly on the left side, you can put x1 of minus 1. What happens when you put x1 of minus 1? This will be x2 of minus 1 minus of minus 1, which is plus 1. So this is x2 of 0, and it goes on like that. But I'm not going to do a bit further, because there is a reason for that. What happens to all the terms on the left side? What will happen to this? What is x1 of minus 1? From this, x1 of minus 1 is 0. So from this, because all the x1 is of the in the negative side, in the left side, you can see that all the product are going to be 0. So you don't need to consider all this is going to be 0. Now what happens at this side? It is x1 of 1 into x2 of minus 2. What is x2 of minus 2? x2 of minus, you have only signal for minus 1, x2 of minus 2 is 0. That means from this side, all this becomes equal to 0. So the available term will be only x1 of 0 into x2 of minus 1. What is this? From this sample, what is x1 of 0? x1 of 0 is this one. So I'm going to put that one into what is x2 of minus 1? x2 of minus 1 is this one. So you must be very careful in taking the samples from this sequence. So the answer is 1. That is x of minus 1. So you found out that x of minus 1 is equal to 1. Okay, so now I'll be doing another one for the next one also for you, that is putting n is equal to 0. So this is the n is equal to minus 1, then putting n is equal to 0. What happens when putting n is equal to 0 in 1? In 1 we get x of 0 is equal to sigma k equals minus infinity to plus infinity x1 of k into x2 of minus k. Now you are going to expand just as I've shown you in the previous. So when k is equal to 0, this becomes x1 of 0 into x2 of 0 plus x1 of 1 into x2 of minus 1 plus x1 of 2 into x2 of minus 2, and it goes on like that. Now on the left side you will have x1 of minus 1 into x2 of 1, and it goes on like that. We know that x1 of minus 1 and minus 2 etc. 0, so all the left side will be 0. What about this? x1 of 0, you have x1 of 0 here, you have x2 of 0 here, so no problem. So similarly, next one is x1 of 1, x1 of 1 is here, x2 of minus 1 is here, so there is no problem. What about this? x2 of minus 2, there is no signal for x2 of minus 2, so all the right hand side after this will be equal to 0. So your x of 0 becomes equal to x1 of 0 into x2 of 0 plus x1 of 1 into x2 of minus 1, right? x2 of minus 1. So what is this x1 of 0? x1 of 0 is 1. What is x2 of 0? x2 of 0 is this arrow mark showing the sample that is being shown by this arrow mark. So x2 of 0 is 1. Then plus, what about x1 of 1? x1 of 1 is x1 of 1 is 1. Now what is x2 of minus 1? x2 of minus 1 is this one, right? Now x1 of 1 is 2. x1 of 1 is 2, right? x1 of 1 is 2, while x2 of minus 1 is 1. So this is 2 plus 1, the answer is 3. That is x of 0 is equal to 3. Now in this way you may find out x of 1, x of 2, x of 3, x of 4 and x of 5, and you may also do x of 6 and x of 7, and while you do that you will be able to get the following answer. Here is it. So x of 1 is also being done for you, that is x of 1 is when you expand you will get like this, you will get the answer to be equal to 5. In this way you may find out x of 2, x of 3, x of 4, x of 5 and x of 6. You are going to get answers like this. So your x of 1 is equal to 5, x of 2 is equal to 7, okay, x of 2 is equal to 7, this is equal to 7, x of 2 equal to 7. x of 2 equal to 7, then x of 3 is equal to 5, x of 4 is equal to 3, x of 5 is equal to 1, and finally you can see that x of 6 and x of 7 are going to be 0. That means when you find out this x of n, you will be getting sequence like this. That is, it starts with x of minus 1 is 1, right? X of minus 1 is 1. Then what is x of 0? X of 0 is 3. X of 1 is 5. X of 2 is 7. X of 3 is 5. 4 is 3. 5 is 1. Okay, now look at this. Let's count this. 1, 2, 3, 4, 5, 6, 7. So your n is equal to 7. And which must be the starting point? This is minus 1, right? So this third has to be represented as the 0th sample, right? So this is SP. Here the SP is equal to minus 1. So this is the result of the convolved signal. Okay, now similarly you can try for this. You may do the signal, another signal x1 of n is x2 of n. Do this as a work, as an exercise using mathematical expression. Find out x1 of n star x2 of n using the mathematical equation. So in the next session we will be dealing with the graphical convolution by doing the same exercise, that is the x1 of 1 2 1 1 and 1 1 2 1, and we need to verify the answers are to be the same. So you may go through this problem, this simple, I will just explain this question. x1 of n is having 3 samples, x2 of n is having 4 samples. The starting point of these two signals are minus 1. So what is going to be the number of samples of the convolved signal? Say let us call this as x of n. X of n, what is the convolved signal? So that's going to be, n is going to be, n and sp you need to find out by yourself. N, I just say n is actually n1 is equal to 3, here it is 4, n2 is 4, n plus 3 plus 4 minus 1, 7 minus 1, n is going to be equal to 6. Well, what is the starting point? Starting point is the sum of the starting points, that is in both the cases it is minus 1. So the starting point, or this starts from minus 2. So you need to find out the value of n from minus 2, then minus 1, 0, 1, 2, 3. That's enough. When it comes to 3, the number of samples becomes equal to 6. After that you may just find out, you can see that all the others are going to be zeros. And this example also you need to find out x of 6 and x of 7 just to prove that all the other samples coming after that is going to be 0. So the total length of this convolved signal is equal to 7. So we'll see the graphical method in the next video. Thank you.